Okay, so for question 27, what we're looking at here is the second law that says x to the p divided by x to the q is x to the p minus q. So all we have to say is 5 minus 4 gives you 1, so we've got x to the 1, which we normally just write as x, but if you wrote x to the 1, it would still be as correct. Okay, question 28. We can use our strategy of going for our numbers and then for our variables, variable by variable. We've got multiplication over here, so we're going to be adding exponents when we get there. Let's start with what's 5 times 1 is 5. Okay, what's x cubed times x to the 6? Well, we know that x to the p times x to the q, when we're multiplying, we just add exponents. So 3 plus 6 gives us 9, so x to the 9, and y cubed times y to the 4, we can add 3 and 4, and we've got y to the 7. Question 30, we've got multiplication, so again we can use the fact that x to the m times x to the n equals x to the m plus n. In other words, if you're multiplying, you add exponents when the bases are the same. What's our base in this case? Our base is 3, so we're going to have 3 to the power of something. And what we have 3 to the power of? Well, what's c plus c? How many c's do we have? We've got 2c, so 3 to the power of 2c. Question 30, we've got division. So we probably have a fraction at the end, so let's put our fraction line down and then use our same tactic as we did for 28. We're going to go for our numbers and then we're going to go variable by variable. So let's start off and I'm going to work it out down here. What's 4 over 6? Or we can simplify that as 2 over 3. So we've got 2 over 3. So those are the numbers sorted. X to the 5 divided by x to the 4. As it so happens, this is exactly the same as question 27. We've got x to the 5 divided by x to the 4. Remember, we'll just go 5 minus 4 gives us x to the 1. So we've got x. And we've got, finally, y squared divided by y. Well, 2 minus 1, because we've got a 1 down here, gives us y to the 1, which is y. If you wanted to, you could write that as 2 over 3 xy. Either way, let's stick with as we've written it down originally. Question 31. We're multiplying, and we know we've done it a few times now. If we're multiplying, then we just add exponents. So we're saying, let's add minus 5 to minus 7. So minus 5 plus minus 7. Well, if you're adding a negative, it's the same as subtracting it. So we've got minus 5 minus 7, which is minus 12. So the answer is x to the minus 12. However, at the top here it does say leave your answers with positive exponents. So if we've got something to a negative exponent, we just need to write that as 1 over x to the positive exponent. So our answer here is 1 over x 12. And you will have to write it as a positive exponent because that's what the question asks for. Question 32, and we're raising a power to a power. And so let's go through this numbers or coefficients and then variables. So let's start with our coefficient of 2. What's 2 cubed? 2 cubed is 2 times 2 times 2 is 8. So we've got 8. What is x squared cubed? Well, we multiply these two, so we're left with x to the 6. What is y to the 5 to the power of 3? Well, we multiply these, so we've got y to the power of 15. Question 33, and we asked x minus 7x cubed. And I must admit, I think this is a strange question to have in this section of exponents, because what it's really testing is like terms. We've got these things x's, and we're subtracting 7x cubes, which are different things. So we can't add unlike terms. So we'll just have to leave it as is. We've got x minus 7x cubed. Okay, question 34. We're looking for the square root of x to the 10. I'm going to add in the 2 here. It's not normally written, but that's by default if you Question 34, we're looking for the square root of x to the 10. I'm going to put the 2 here because it's the square root, we just don't write it for convenience. But for cube root, fourth root, etc., you do write the number. Let's start with our law. We're going to look at this in a few ways. And the law says that if you're taking the root of some number, let's say x to the p, and we're taking the qth root, so in this case we're doing the square root, then you simply divide it, p divided by q. So in this example we've got x to the 10, we're taking the square root, so it's x to the 10 divided by 2, which is x to the 5. Now let's look at an example with numbers without using that law directly. And say, well, what happens if we're looking for the square root of 16? Well, we know that's 4. Why do we know that? Because 4 squared gives us 16. So let's look at it for this example. The square root of x to the 10 equals, we know it's going to be x to the something. So I'm going to put x and leave that space for that. So it's going to be x to the what? Well, it's going to be x to the something squared should give us x to the 10. The right hand side of this part here, well, what squared will give us x to the 10? Well, we know that we'll multiply these two. So if we put a 5 here, 5 times 2 will give us 10. So this is x to the 5, because 5 times 2 is 10, or 10 divided by 5. And hopefully you can see that these two laws here kind of work hand in hand. And let's look at it as one final way and say, well, and this is kind of the same way as square root of 16 is 4, because 4 times 4, something times itself, that's what squaring means, is 16. So the square root of x to the 10 equals x to the something or other, because that x to the something or other times itself is going to give us x to the 10. What number can we put in here? Well, when we multiply, then we add exponents. So 5 plus 5 will give us 10. Therefore, the square root is x to the 5. Whichever way works for you, square roots, you can apply the law, because then you can apply it to cube roots and fourth roots and beyond, but it's useful to think of it conceptually in the other ways as well. So let's fill that in, x to the 5. Question 35, and there's quite a lot going on in this question. It's quite a tricky question in a lot of ways. We're saying minus x to the minus 2 all squared. And let's tackle this in two ways. The first way is going to be more using the laws. And I'm going to put in a 1 here, because if it's minus x squared, it's the same as saying minus 1x, or sorry, to the minus 2. And let's do the same as that we applied in question 32. We're raising a power to a power. Let's start with our coefficients, our numbers, and move into our variables. So let's start with the minus 1. What's minus 1 squared? Well, it's positive 1. Anything squared has to be positive in the real number system. So we know that it's going to be 1. So our answer is going to be 1 something or other. Then let's look at our next part. What's x to the minus 2 squared? Well, we just multiply these, so we get x to the minus 4. So we've got 1x to the minus 4. But, which we just write as x to the minus 4. But it does say positive exponents. So like in question 31, we're going to have to turn that into positive. So x to the minus 4 is the same as 1 over x to the 4. Now, in all likelihood, some people would have said minus 1 over x to the 4, or something along those lines. Let's look at it a second way, not using the power to a power way, but let's say, what does squaring mean? Squaring means you're multiplying by itself. So minus x to the minus 2 times minus x to the minus 2. What's a negative times a negative? A positive. So I'm going to put the plus to show that it's a positive. Now all we have to do is say, what's x to the minus 2? I'm just going to do it here. X to the minus 2 times x to the minus 2. Because we're multiplying, we add exponents. The bases are the same. So this is x to the minus 4. and we've got x to the minus 4, same thing as before. We need to convert that to a positive exponent, so it's x to the 4. I would use the power to the power. I'd use this method that we've done on the left, but on the right kind of explains why we get that positive in a different way. So we've got positive 1 over x to the 4.